For the last topic, I want to look at a couple of applications where solving quadratic equations by factoring would be involved. Okay, so quadratic equations are really cool. They have lots of real world applications. We're going to look at a couple of simple applications here. So example 4 says solve each problem, include correct units with your answer. Now, I've said this before in previous videos, but you're in an algebra class. Your instructor wants to see algebra. So you can play around with the numbers and just sort of get lucky and come upon the answer, but I'm still going to be grading the algebra. So you have to show me the model, the equation that you're working with, and then how you solved it too. Okay. So for part A, we have the width of a rectangle is 4 feet less than the length. If the area of the rectangle is 117 square feet, find the length and width of the rectangle. Well, we have two things going on here, length and width. And for me personally, I like to assign a variable that is different than length and width. I just do. It's my personal thing. You could certainly use a W or an L, but I like to use an X here. Okay. So we're going to have to go back to this idea of direct translation. We've done it tons in this class. Okay. We need to assign a variable to what we don't know. We know that the width of a rectangle is 4 feet less than the length. We don't know anything about the length technically. So I'm going to go ahead and say, okay, the length is going to be X, whatever, X units. So X feet in this case. If the length is X, then the width would have to be the same, X minus 4. So I'm going to say the width is X minus 4. And we also know that the area is 117. Now we're dealing with a rectangle. And aside from the area being 117, you also need to remember the formula for the area. The area of a rectangle is length times width. So I want to take these values right here and I want to plug them into this formula. Okay. So I'm going to say, okay, 117 equals the length, which is X, times the width, which is X minus 4. Okay. Now we know to solve a quadratic equation, we need to put it in standard form. So it may not look quadratic at this point because we don't see an X squared term, but when I distribute this X through X minus 4, we'll get that squared term that we want. So I've got 117 equals X times X, which is X squared, and then X times negative 4, which is negative 4X. Now I need to put this in standard form. It's almost there, but not quite. So I want to go ahead and subtract 117 from both sides. And then when I take that 117 and I subtract it, I'm going to put this in standard form. I like to have the quadratic part on the left and then the constant on the right. So I'm going to notice that 117 minus 117 is 0. And then x squared minus 4x minus 117 looks like this. I'm just going to go ahead and write it quadratic on the left, 0 on the right. Okay, you could leave the 0 on the left and the quadratic on the right. No big deal. I just like this format here. So we luckily have a quadratic trinomial where a is 1. Okay, so we can go ahead and jump straight to this point. What we're doing is we're looking for factors of negative 117 that have a sum of negative 4. And so 117 is a little bit tough. We're not used to dealing with 117 as a product. So let's go to the calculator. I hope I have the calculator up. I do. And what we're going to do is we're just going to take our 117 and we're going to start dividing by integer values until we get integer pairs of factors that we can work with, okay? If you get decimals, toss them out. So we know 117 divided by 1 is just 117. Divided by 2, decimal, toss it out. 117 divided by 3, we have 3 and 39. So that's a possible factor pair. So we need to remember 3 and 39. 117 divided by 4, decimal, toss it. 117 divided by 5, decimal, toss it. 117 divided by 6, decimal, toss it. 117 divided by 7, decimal. 117 divided by 8, decimal. 117 divided by 9. Ooh, I like this one. Now we can play around with 9 and 13 and get a sum of 4, okay? So let's go ahead and stick with 9 and 13. We could keep going if you wanted to. 117 divided by 10, 117 divided by 11, 117 divided by 12, and then 117 divided by 13, we already know is going to work. So once you see your factors repeat, you're done. Okay, so the only two pairs that work for us would be 3 and 39, and then 13 and 9. So let's see what we've got here. Okay, so again, we know our factor pairs are 3 and 39, and 9 and 13, but let's figure out signs. Okay, we know we need to have a product of negative 117. So that means one of the factors has to be positive, one of the factors has to be negative. And we need to have a sum of -4. So that means the larger of the factors needs to be the negative one. So I could say I have 3 and -39, or 9 and -13. And if I look at 9 and -13, if I add those, I get that sum of -4. So this is my pair of factors that's going to work. So down here, I want to go x plus 9, x minus 13, and I want to solve. So we have a product equaling 0. So we're going to apply the zero product principle and set each factor equal to 0. Well, if I have x plus 9 equals 0, I need to subtract 9 from both sides. So that gives me x equals -9. If I have x minus 13 equals 0, I need to add 13 to both sides, and I get x equals 13. Well, let's stop for just a brief moment and think about this. Oftentimes when you're dealing with an application where you're going to have more than one solution, so something, for example, quadratic, where we're going to get two solutions, one of the solutions may not fit the application. It's still a valid solution to that generic equation, but it doesn't work for the application. And in this case, we know that x is the length of this rectangle. Well, length has to be positive. So we can go ahead and just toss x equals 9. This doesn't fit the application. It'd be really cool if I could spell, huh? Let me scroll down just a smidge. Doesn't fit the application. Let me rewrite that. So it just doesn't fit the application because we can't have a length that's negative, okay? So that tells me right off that my solution is 13. But when you're solving an application type problem, you can't just solve the equation and stop there. You always have to relate your answer back to the application itself. So we know that we had that length was equal to x, and we now know that x is 13 feet, okay? We know that width was x minus 4, or 13 minus 4, which is 9. So we now have the dimensions of this rectangle, and if we wanted to check it, we easily could. We could say, okay, is 117 equal to 13 times 9? Yes, it is. So generally speaking, when you're dealing with an application, you want to describe your answer, and I didn't set this up nicely where I had a lot of room, but I would want to say something like the length is 13 feet, and the width is 9 feet. When you're dealing with an application problem, you need to make sure that your answer is very clear, especially with the way I set this one up. I didn't plan this one out ahead very well, so I was kind of bouncing all over this little square, and it can make it hard for your reader to find your answer. So make sure you have your answer written out with a nice description very clearly for your reader. Okay? Now, finally, we have if h equals -16t squared plus 96t represents the height of a rocket in feet t seconds after it was fired, when will the rocket hit the ground? So we know a couple of things. We know h equals the height, and t equals the seconds. So like after the rocket has been fired, we start counting, and however many seconds pass is t. We want to know, when will the rocket hit the ground? Well, what does that mean? If the rocket hits the ground, what is the height of the rocket? Well, the height of the rocket would be 0. So we want to find t when h equals 0. So I want to take this equation up here, and I want to make sure that h equals 0. So I get 0 equals -16t squared plus 96t. Okay? So I have a standard form equation, and right off the bat, you might be like, ew, it's got that negative lead term. It does. It was set up that way. We'll just factor out a negative GCF. Okay? So we do want to see if we have a GCF. We definitely have a t as a GCF. Okay, so we can factor out at least a t. But let's look and see if we have another factor that can come out. So we've got factors of 96 and 16. So let's start and just see if 16 is a factor of 96. So let's go to the calculator. So we want to take 96 and divide it by 16. If we get an integer value, that tells me 16 is a factor of 96. And it is. So we can say that 96 divided by 16 is 6. So keep that in mind, the 6 and the 96 and the 16. Okay. Good grief. Let me go back to the worksheet. Sorry, y'all. Why is it not wanting to go back to the worksheet? Let me do it this way. Let's see if it'll let me go back this way. There we go. Okay, sorry about that. So we do have a GCF here. We have a GCF of negative 16t. So remember from a long time ago, when you have a negative lead term, and our lead term is the squared term, when you have a negative lead term, you need to factor out a negative GCF. So we have a GCF of 16t, we need to make it negative. So I get 0 equals negative 16t times stuff. So I'm going to divide each of these by negative 16t. Well, negative 16t squared divided by negative 16t is just going to be t. And then 96t divided by negative 16t. Remember, 96 divided by 16 was 6. So we're going to get just negative 6. And now we have a product that equals 0. So we can take negative 16t equal to 0 and t minus 6 equal to 0. Well, if I have negative 16t equal to 0, I need to divide both sides by negative 16. Well, the 16s cancel to become 1, so I just get t equals 0. And if you think about that, that kind of makes sense. We have a rocket, it starts on the ground, and then we fire it, and it's going to make a shape, and then it's going to end up on the ground again later. Well, when time is 0, the rocket is still on the ground. So when t equals 0 seconds, the rocket is still on the ground. And then finally, we have t minus 6 equals 0. To get t alone, I want to add 6 to both sides. 6 minus 6 is 0, leaving me with just t, and then 0 plus 6 is 6. So we could say at 0 seconds, but more importantly, after 6 seconds, we know that the rocket has hit the ground. So we would say the rocket will hit the ground after 6 seconds. And that's your final answer. So just remember, with these applications or these word problems, make sure you put a description with your answer and make it very obvious to your reader. And that's it for this chapter, this section. So you need to really practice your factoring methods, because in the next chapter that we're going to look at, it's rational expressions, but more importantly, you're going to be factoring almost every single problem. So make sure you have practiced your factoring inside and out.